Welcome to the video lecture on CS3251 Programming in C Unit 3 Functions and Pointers. In this lecture, we are going to see two topics, pointers and types of pointers. In the previous lecture, we have seen about the functions and how to create the function and two types of functions. In the last, we have seen the recursive function. In this lecture, we are going to see about pointers and its types. So coming to pointers, what a pointer is, it is nothing but a variable which stores the address of another variable. That is a pointer. A pointer is nothing but a variable. It is also a variable, but it stores the address of another variable. It is not going to store any other values. It is going to store the address of another variable. So this variable, this pointer variable can be of any data type, that is it may be integer, it may be character, array, function, or it may be a type of any other pointer. So the data type depends on the variable whose address the pointer is going to store. So based on that target variable, the data type of this pointer depends. The size of the pointer depends on the architecture. Usually this pointer is going to store only the address. It's not going to store any integer value, character value and all. It is going to store only the address of another variable. The variable may be an integer, character or anything. They are going to store only the address, starting address of that variable. So the size depends on the architecture, not on the type of data. So in 32-bit architecture, the size of the pointer is 2 byte. So next we will see how to declare a pointer. So for declaring a pointer, we have to use the symbol asterisk. So whenever we want to create a pointer, we have to use the symbol asterisk, and this asterisk is called as dereferencing operator. So if we want to create any pointer, we can use the data type for the pointer, then we have to use the asterisk symbol. That is, this asterisk symbol is called as dereferencing operator. It is a unary operator. So then the name of the pointer. So this data type depends on the variable which this pointer is going to store the address. So based on that target variable, the data type of the pointer differs. So this is the simple way of creating a pointer. For example, here we have created two pointers P and C. Here we can see the data type of the pointer is integer, followed by the data type we have to specify the asterisk symbol. So this is the dereferencing operator. So I will explain what dereferencing operator is. So in this declaration, this pointer is of character type because this pointer is going to a variable which is of character type. So for example, I am declared two variables, int n, int star p. Okay, what will happen is, since p is a pointer, it is going to store the address of another variable. So this is the notation used to denote the pointer. So n is a normal variable, so we can denote a normal variable like this. So this is a normal variable, but this variable is going to store the address of some other variable, so we can represent the pointer like this. So pointer is nothing but a variable which is going to store the address of another variable. It is not going to store any integer, character, float, double values. It is going to store the address value only. Its data type depends on the variable to which it is pointing. So in this example, you can see that here we are having two variables A and B. A is initialized to 7 and we didn't initialize the b variable. And in the next line we have created one pointer p and its data type is integer. It denotes that this pointer is going to point a integer variable, that is it is going to store the address of a variable which is of integer type. So to store the address for this pointer we have to use the statement like this: p equal to ampersand of that target variable. So here our target variable is a. So here our target variable is a. So we have used this ampersand symbol, and followed by that we have given the target variable. So this ampersand symbol is called as the referencing operator. There are two important operators associated with pointer, that is star and ampersand. These are the two operators associated with a pointer. This star is called as a dereferencing operator and this ampersand symbol is called as referencing operator. Whenever we use ampersand symbol in front of whenever this ampersand symbol presets a variable, what it will do is it will return the address of the following variable. So I have used the ampersand symbol in front of a. So what will happen here is this will return the address of the variable a. So suppose the variable of a is stored in the address 2000, means whenever you use an ampersand symbol in front of this variable, this ampersand symbol will return the variable's address. So here what will happen is p is assigned to the value 2000. Since p is a pointer, it stores the address of the variable a. So here the address of the variable a is 2000. So ampersand symbol is the referencing operator. So what here will happen is the address of the variable a is referenced and it is stored in the pointer variable p. In this line what is happening is here we are dereferencing the pointer variable. So I have told you asterisk symbol is used for dereferencing purpose. Dereferencing purpose means here we have created a pointer p and maybe the location memory address for the pointer is 5000. By using this statement here the value of pointer is 2000, means that it is pointing the variable a. Already we have initialized the variable a as 7. Whenever we are using the dereferencing operator preceding the pointer, then it will directly points to the value present in this address. So here the address stored in p is 2000, so it will directly go to the address 2000 and it will find the value inside that address and it will return that address. So we are saying star as a dereferencing operator. So when asterisk symbol precedes a variable, pointer variable, it will perform dereferencing. That means it will go to the address stored in this pointer variable and it will return the value stored here. So what will happen? This will be replaced by the value 7 and it is assigned to the variable b. So this is what happening. So here you can see that by using the we have created a variable a and its memory address is 4000 and we have initialized the value of a to 7 and we have a pointer. When pointer is referencing the variable a, then this address will be stored in the pointer. When we use the dereferencing operator, then it will go to the memory address and it will dereference the value stored in that address. So whenever we use the statement p equal to star p, then there will be dereferencing will occur. So the two main operators associated with the pointer is asterisk symbol and ampersand symbol. Ampersand symbol is called referencing operator. Star symbol is called dereferencing operator. Whenever this star symbol precedes a variable, it will return the address of that succeeding variable. Whenever this star symbol precedes a pointer, it will dereference the value pointed by that pointer. So we will see another example for a pointer. Here we have created one variable named number and we have initialized to 50. Then we have created a pointer p. Here in this statement we have reference the address of number to p, that we have assigned the value for p. So here you can see that to print the value stored in p, we have to use the symbol %x. Since for integers and all we use control string %d, but to print the address value we have to use the control string %x. This %x will be used whenever we want to print the address of a variable. Since we are having the address in the pointer variable, when we simply give the variable name without any preceding operator, then it will return only the address stored in that p. So we are using the control string %x. Here we are using the dereferencing operator. We know that this pointer is pointing to a integer variable. So whenever we are dereferencing, it will return that integer value. So we are using the control string %d. So you can see that this is the address of the variable number. We know that when we use this statement p is equal to ampersand number, it will store this value in the p variable. So whenever we try to print the value stored in p, we will get the address of the number variable. So to dereference the value pointed by the pointer, we can use the star p. So we know that star is a dereferencing operator, so it will print the value stored in number. So by using the diagram we can understand. For example, this is the variable number. It is allocated in the memory triple F4. So this is the address of the number variable and the value stored in is 50. We have created one pointer p, and when we execute this statement, this address is moved to the pointer variable. So when we try to print the value stored in p, this address will be printed. So only the output is like this in this line. So when we want to dereference, that means when we precede the variable p with asterisk symbol dereferencing operator, it will move to this location and it will return the value stored in that location. So we get the output as 50. So these are about the pointer. So we will see about the advantages of pointer. So what a pointer is, the pointer is very helpful for accessing the memory location. Previously we can see that we can able to access the memory directly from somewhere else by using the memory address, and also it is an efficient way for accessing elements in the array. So we will see in the later lectures how to access the elements inside the array, and also we can use this with other data structures like trees, graphs and linked list. And also this pointer is helpful in creating the dynamic memory. So instead of creating a static memory, we can able to allocate the memory, whether our memory allocation will grow or shrink by using this pointer. So dynamic memory allocation is possible only because of this pointer concept in C. So these are the advantages of pointer. First one is we can access the memory directly, then we can use this with array. We can able to access the array element by using pointers. We can able to create dynamic memory, and also it will be used with to create the complex data structures like linked list, graph, trees and all. We need the help of pointers. So these are the advantages of pointers. Next, the disadvantage of pointer is it is little bit complex to understand the pointer concept, and also if we didn't initialize the pointer variable means it will throw a segmentation fault. Whenever we created a pointer and we didn't initialize any value and we didn't use that pointer means it will throw the segmentation fault. We have to provide correct value for the pointer, else it will lead to memory corruption. And also we are accessing the memory directly, we are responsible for the memory leakage. So that means the data will be used directly without using a variable. So we have to be careful in using the pointer. So these are about the pointer. Next we are going to see about the types of pointer. The first one is null pointer. So null pointer is nothing but when we create a pointer and we are initializing the value of the pointer as null, then the pointer is called as null pointer. So at the time of declaration we don't have any value means we can simply initialize the value of the pointer as null. So like this, so int star p equal to null. So this is a macro constant. So we initialize this pointer with the null whenever during the declaration. If we don't have any value to initialize mean we can initialize this pointer with the value null. If we didn't initialize the pointer means it will take some garbage value, but we use null means it is a defined value. That is the use of initializing the pointer as null. If we didn't initialize mean it will automatically take some garbage value. To avoid that we are initializing the pointer as null. So next type of pointer is void pointer. Void pointer means I already told that the type of the pointer depends on the variable to which it is pointing. So if I don't know to which variable this pointer is going to point means we can create a void pointer. We already seen in the function declaration, void means we are not going to return any value means we simply create a function with the return type void. Similarly, if I don't know to which variable this pointer is going to point means we can create our pointer as void. So it is also called as generic pointer. So this pointer can point to any variable. The variable may be of integer, character, float or double. This void pointer can point to any type of variable. So at the time of declaration I don't know the type of the variable means I can simply create a pointer with void data type. So we are saying it as generic pointer. So this is the syntax for creating the void pointer. Simply we have to use the keyword void, then we have to use the declaration. Important thing is void pointer cannot be dereferenced. We have previously seen that to dereference the address pointed by the pointer we have used the symbol star p. So that cannot be done in the void pointer. And also pointer arithmetic cannot be allowed here. So we cannot perform any pointer arithmetic operations in void pointer. So what is the difference between null and uninitialized pointer is null pointer has a defined value, like if in the case of integer it is 0, in case of string it is null, like that it has some defined value. But if it is an uninitialized pointer, it will have undefined value, that means some random value, or we can say it as garbage value. The next type of pointer is dangling pointer. Dangling pointer means if suppose there is a pointer p and it is pointing to some memory location, and if that referencing memory is deleted means this pointer becomes a dangling pointer. So a pointer pointing to a memory location and that memory is deleted means then our pointer becomes a dangling pointer. There are three different ways when where the pointer becomes dangling is. First one is deallocation of memory. In this case, we have deallocated the memory, so our pointer becomes dangling pointer. Second case is during function call. When if our function returns a local value, then our pointer becomes a dangling pointer. During function call, the value returned by the function is a local variable, then our pointer will become a dangling pointer. Similarly, if our pointer stores the value of local variable and that local variable is out of scope, then our pointer becomes dangling pointer. So the last one is wild pointer. So wild pointer is nothing but an uninitialized pointer is called wild pointer. A pointer that has not been initialized is called as wild pointer. If the pointer is not initialized but it is initialized to null value means that pointer will be changed as null pointer, but we didn't give any value to the pointer means then the pointer is wild pointer. So in this example you can see that we have created a pointer, declared a pointer, but it is not initialized. So now this pointer p is called wild pointer, but in this statement our pointer is initialized to the address of the variable x, so this pointer is not a wild pointer now. So this is the wild pointer. So we have seen some types of pointer. First one is null pointer, second one is void pointer, third one is dangling pointer, fourth one is wild pointer. So these are about the pointers, and an important thing is whenever we can able to use the statement p is equal to ampersand x, or we can use this in a single line like int star p equal to ampersand x, but we should not use a statement like star p equal to ampersand x. This statement is illegal. This statement is not a legal statement. Whether we can declare a pointer in one step, then we can initialize a pointer like this, or we can combine these two steps as int star p equal to ampersand x. So in this statement we done both declaration and initialization. So these two statements are legal, but we cannot write a statement like star p equal to ampersand x. So this is a illegal statement. So these are about pointers. A pointer is nothing but a variable which stores the address of another variable. The type of the pointer variable depends on the variable whose address we are going to store. So here we are storing the address of the integer variable. So our data type of the pointer is int. If we are storing the address of a character variable, then the data type of our pointer is character. So the two operators associated with the pointer is star and ampersand symbol. Star is a dereferencing operator and ampersand is a referencing operator. Whenever this ampersand symbol precedes a variable, it will returns the address of that variable. So when we use ampersand a, then it will return the address of this variable. Similarly, whenever the dereferencing operator precedes the variable, it will be preceded only the pointer, so that dereferencing will happen. So these are about pointers. Thank you.